Hello, everyone. Welcome to this webinar on embedded vision. So I think we've got around 30 odd people. We can start off with the webinar and add more people on the go as such. So let's have a short round of introductions where I introduce myself, I introduce the panel, and we will have a brief introduction on the topic as such. So I'm Abdur. I'm a global client partner at SmartSoC. I also head the sales for Europe region for the embedded systems as such. I have with me on the panel Mr. Srinivas Gupta. He is the CTO of SmartSoC, an IITian who completed his master's from IIT Madras, one of the prominent institutes in India. He has been in the semiconductor space for a good 25 plus years now, and he would be sharing his experiences and his knowledge on the cameras and on the vision part as such.
Thank you, Abdur, for introduction. So I am Srinivas Gupta. I have 25 years of experience in semiconductor industry, and my master's in digital signal processing. And I worked extensively in chip design activities and system design aspects and other things. So this is very close to my heart, where my entire knowledge in education and experience will help. And what is motivated us to give embedded vision webinar is the considering our request from customers and other. So we'd like to share our expertise and whatever pain points others are having. Based on that, we designed an entire webinar. So this is, yeah.
Understood. So let's move on to introducing the topic of the hour, embedded vision. I mean, most systems these days come with a prefix of autonomous, right? You have autonomous vehicles, autonomous shopping, autonomous robots, autonomous broadcasting, etc. All these systems get autonomy through some sense. I mean, cameras also are the forefront of the sense that gives autonomy. So we also call it the sense of autonomy as such. So we'll try to understand how camera and vision systems are helping innovation, helping systems become more smarter, and helping them take decisions on their own. The agenda for the discussion will be shown on the screen. So what we'll try to do is we'll initially understand what is embedded vision. So there are different genres of say computer vision. You have machine vision, you have embedded vision. We try to understand what embedded vision is, how different it is from machine vision, and what is it that is driving this innovation using embedded vision. Then we try to understand how the market has grown over the years, basically to get an idea of what kind of innovations are taking place and how the innovation is contributing to the growth in the vision sector. We also try to understand the factors that help embedded vision sector grow. There can be various factors like the advancements in technology and all that. We'll try to look at them. We'll try to bring in some of the new age applications that are there in the vision space, just to give us an idea of what kind of vision systems are in use. Post which we'll go into the basic construct of the camera as such. So the idea is to understand the different vision systems, different applications, and then understand the camera part at a block level and see what are the various things that you need to look at when you're trying to select a camera, right? What are the specifications you need to look at when you're trying to select a camera, and what are the various components in a camera that help you make the decision basis your application. After which we'll have a Q&A session to understand more on your doubts and try to resolve your queries on the vision part as such. So then this is what we have on the agenda. This is what we would like to share with you. We have Srinivas, as I said. So Srinivas will start with the question in our minds. The basic question, the first part of the agenda, which is what is embedded vision?
Yeah. So vision means we can see whatever it is, correct? What is meant by embedded and machine vision, and so many vision words are there. So embedded vision means along with the eye, you need to add brain. Okay. So put together, it is embedded vision. That means capturing data, videos, and taking a decision based on whatever videos captured. So if it is only recording and displaying and all that, that is only vision. But embedded vision means we need to take a decision based on what is available. Okay, that is embedded vision. So most of our applications are real-time applications. Nowadays, whatever is appearing, those are embedded vision. So whatever decisions we are taking, it is autonomous vehicles or guided vehicles and robots and so many things. We capture videos and take a decision based on real time. Okay, so that is all embedded vision. Okay.
Understood. Understood. So you mean to say that whenever there is, say, a visual data that comes across, if the decision making is done, say, with human intervention, where some kind of human intervention is needed in terms of what decision has to be taken basis the data, then it is not embedded vision. And if it is completely on the edge, and if the machine autonomously is able to take the decision basis the data that is shared with the machine, then it is embedded vision, right?
Exactly. Yeah. So latest advancements made us easy to make it embedded vision. Let's see.
Understood. Understood. So now that we understand what embedded vision is, we would like to understand how has the market grown over the years, just to understand how the technology has advanced and what are the factors that are contributing to it and all of that. If you could give us some idea on how the market has progressed and what is the future of the market in the embedded vision space.
Yeah, you can see the growth chart of entire vision market. Okay, it is showing 2020 to 2030, the 10 years growth. So if you see here, this year we can see 25.8 billion USD, and last 4 years, so it reached to 9.6 billion USD if you take it from 2020, and so there is an exception at 2021 where COVID situation made very peak in the demand, and later some correction happened. Okay, so apart from that, it is consistently growing at 10.5%, and the key regions are Japan, Korea, Europe, and even entire world is there. Yeah, so market is very huge, and consistently it is growing.
Understood. Understood. So there's a spike in between for 2020, that is because of COVID. I'm assuming that is because of a lot of new age applications that came in to avoid human intervention, and then there was a market consolidation, right?
Correct. So particularly COVID, should not touch, and everybody should work remotely and all of that, correct? Without human touch. So that
Understood.
made different applications came up, and vision related, embedded vision related growth happened much.
Understood. Understood. Great. So, what are the factors that are contributing for this growth? I mean, when we say it is going to triple in a few years' time, it is going to hit, say, 45 to $47 billion by 2030. The CAGR also seems to be about 10%. What is it that is driving this market to grow at this level?
So there are various factors. We can see four prominent ones. One is technical advancements in chip design and manufacturing. Okay, so in olden days where I started career, that point of time it is even 90 nanometer and 180 nanometer technology node where chip size is bigger. And nowadays we are working on 2 nanometer, which is a SmartSoC capability, where we are able to work on advanced technology nodes. The chip size is very small and without compromising the performance or quality of the chip. So this is making a huge impetus or a major factor for embedded vision growth. Why? Because we need to take a decision real time. That means whatever video we are capturing, we need to process it and take a decision. So it is a latency should be less. So we need to take a calculate faster and make a decision. So all these are possible because of the advancements in the chip design. Okay, it's Moore's law is the one which is dictating this one. Now we are reaching saturation level of even Moore's law. So this is the major factor for entire growth. Okay, so this is the basic one. The other layers are also very important, but it is a basic one, which is driving growth.
Understood. Understood. So there's a lot of miniaturization adding to more logic and a lot of data for AI to analyze, which is leading to a lot of innovation. We also wanted to understand, like, what are the segments that you see coming up? I mean, what are the applications of cameras that are really showing a lot of impetus?
There are many smart applications are coming without human intervention. Can you go back? Okay. So there are various applications like various fields, autonomous vehicles or agri or healthcare, and so many other fields, okay, where human intervention is not required. And there are laborious works and mundane work where human intervention is not required, like securities and all other security field, and even medicine and agri and all other. Okay, we can human intervention is not at all required. Those applications we are there, and number of applications are increasing. So that's why it is.
Understood. So when we say autonomous vehicles, so these are vehicles which will have cameras around merged with other sensors like lidars and everything, and they try to run autonomously without a driver as such.
Yeah, autonomous vehicle is the best example where we need to observe the entire atmosphere and road, all the directions. So front, rear camera and side cameras all together, and we need to process it together, and even other sensor data also need to process. Okay, like a lidar and other whatever you mentioned. So all those sensors information need to process and take a decision. So camera is the best one for entire image and information capturing.
Understood. Understood. So that is what sensor fusion is. You have different sensors fused together, synchronized, and you try to take a decision, right?
Exactly.
Understood. Understood. So how is the AGV or AMR sector? Primarily, I believe it is in the logistics space.
Yeah. Guided vehicles or automatic robots or all other things. There are place and applications also increasing. Okay, so even Amazon and even manufacturing facilities, warehouses, these are well used. And best example is China, where entire port is digitized and they are using AMRs and ACV, and they are working on a very large scale. It is already implemented. So applications are more and the successful stories also there.
Understood. Understood. So we see a lot of innovation in the agri-tech space as well. So that is primarily with respect to vehicles, or there are other innovations?
It will have multiple things, okay, like harvesting and also soil testing related and health of the crop. So many applications are there where embedded vision will help. Okay.
Understood. So, what is the use of a camera, say, in terms of soil testing or in terms of other agri-related applications?
So, see, when we observe the soil, okay, based on color and other sensor application, also we can use it. And this is one parameter we can use it, okay, to identify harvesting is the best example, which is a fruit is ripe and a vegetable is good for harvesting or not. So those decisions we can take based on color, texture, and all other things. Okay, so
Understood. So how about the smart cities or related applications, like you have surveillance, you have traffic monitoring? What is it that is catching the cameras here?
okay, surveillance, either it is at home or office or industry, so many activities are there. And we say in at least a residential application where elder persons are at home, we are at remote places, automatically it will observe what is happening at home, and if something is need to attend immediately, so it will call for all the immediate family members. Okay, those type of decisions will be taken and communicated well. And traffic monitoring and smart cities based on situation of the traffic, so diversion and all other activities can be done. And many applications are there. Even parking places in smart cities, okay, where we can automatically read the boards, okay, nameplates, and see where it is available, and we can check all the penalties whatever a driver having and all of so many applications are there. Okay, so pattern recognition and image.
Understood. Can you touch a little bit on the autonomous shopping and autonomous broadcast? So we do have things going into future.
Yeah, that is also one application area where smart. See, Amazon is the best example. They already proven, and its proof of concept is ready, and it can be applied for many other places as well. Okay, so simply we can take whatever items we need from the shop and put it in cart, and we can, while crossing the final gate, it will automatically detect from our wallet. Correct. So this is everything will be seamless. Entire thing is possible based on embedded vision.
So now that we have an idea of the kind of application, the kind of market, we would like to know what the construct of the camera looks like, and what are the various components or blocks that we working with. What helps person working on what application
Nice.
select the right kind.
Next slide. Yeah, that is a camera construct where it is the major important point to discuss, which is a very interesting to everyone. Okay, so camera construct. Okay, where can you go to next slide? Okay, where lens is the one. Okay, which is the first one where light will fall, and then next to lens is the sensor. Okay, sensor. After that, you will have a ISP signal processor. Then there is another processor in between. We will have a interface. Okay, so we'll have a software part and other things that will complete. Okay, yeah, this is the slide we are saying. So important point is here lens. Okay, there are more specific, so depending on application, so what type of lens need to be used. Okay, like whether you need IR filtering or not. Okay, and what size of the camera lens. Okay, there is a equation between sensor and the lens. Okay. Generally, camera lenses are round, circle, correct, and sensors are in square or rectangles. So these diagonal of sensor should match with the diameter of the circle, lens circle. Okay, that is the rule we should follow. Okay, that is one aspect. And the lens size will vary. Okay, 1 inch to okay, 1/4 of inch to 1 inch. That is the available lenses. Okay, so another factor is the field of view. Okay, if you want to be field of view is very high, so we need to take it differently. The distance between lens and the sensor we need to define. Okay, that is the major factors. And the next is the sensor, okay, which is the heart of entire camera. So we need to see a sensor 3 parameters like resolution and sensitivity and even dynamic range required or not. So these things are very important while choosing the sensor, okay. And also, is it a monochrome or color, okay. So there are applications, different shutter is required. Example like a global shutter, where we capture the image at once and processing it line by line and sending data also line by line. Whereas rolling shutter will capture image line by line and also send the data line by line. Okay, so wherever speed is there, okay, where you are capturing speed objectives like a car, a train, and airplane, those type of things, if you want to capture, global shutter is required. But if you are focusing on the quality of the image, where there are no moving objects or less moving, then we can go for rolling shutter. So these are the aspects. So color and monochrome. So monochrome is the one where you will have a majority of the information. Okay. So depth of the any image will tell, okay, how this entire scenario of the, okay. So, but if it is color, for a human, color is important one. So if you are using it for industrial application, monochrome is better, where you can take a decision based on what videos captured. Okay, that is good enough. Okay. So there are various light conditions, correct? So maybe some application you need to observe daylight as well as night light, okay, under different seasons and other things. So different sensor need to play, okay, and also dynamic range, high resolution dynamic range, whatever range you are looking at. So these are the aspects we need to see for selecting the sensor.
Understood. So there are certain sensor parameters like, say, dynamic range or sensitivity or resolution. These form the major selection criteria based on your application. For example, if you want to capture large data, higher distance, if you want crisp data, accurate data, then I believe resolution is important because you want the image to be broken down into smaller parts so that the clarity is there. And then basis what kind of lighting conditions you're using. And if it is broad outdoor conditions, then probably the dynamic range comes in. And in low light conditions where the light is less, the sensitivity of the sensor should be very high. Correct?
Yes, correct. These are the main factors: sensitivity, dynamic range, and color or monochrome or shutter, what type of shutter. These are the major factors while selecting sensor.
Understood. Understood.
So there are different sensors like CMOS and CCD and all other. So CMOS one is the fastest one, another, but still some application like space and application CCD is better. Okay, quality is very important and sensitivity is very high there with you. But all other applications we see CMOS image sensor is the correct one, where the accuracy, quality, and even fast we can take it. So that's how CMOS image sensor is better.
Understood. Understood. So we have the sensor, then we have the optics. And in terms of optics, we will look at the sensor size. Basis that will decide on what mount we need to go with. Say
Yeah, there are S mount and C mount and CS mount, and so many 3 variations are there. Based on our applications, we can pick one.
Understood. And the diameter of the lens should match the diagonal of the sensor, so that you can use a complete resolution of the sensor.
Correct.
Understood. And you also decide on the FOV basis what is the area you're trying to capture.
Field of view based on width and height. So all the 3 parameters we see for field of view, and then distance between lens and sensor.
Understood. So this forms the sensor and lens combination. And then what is the image signal processor? I mean, you send the data from the sensor to the image signal processor.
This is a nest to the sensor where you can send data as a raw data or even debayed data. Okay, what is debayed data means? It is a color where data need to be represented in RGB values. But whereas raw image will have one single value. So, but debayed data will have 3 RGB for each one will have a different value. So each pixel will be represented by 3 values in debayed one. Okay, so this image signal processor will do the entire debaying one function, and also noise removal and image segmentation and whatever processing we need to do it, like color sharpening and gamma correction and contrast value changes, and these are all very important factors. So basic when you say in industry format camera tuning or image quality tuning, this is the one where we set all our parameters required. Okay, generally when we pick sensor and lenses and ISP altogether, then we need to tune according to our need. So what are the color quality required? Are we capturing color properly? Okay, that means if your object is banana yellow, that should also reflect as yellow, correct? So these parameters need to set. Okay, so the tuning part required, so correcting or setting proper values for all these parameters. So
Understood. So what I understand is when the sensor captures the image, the data is still in the electronic format of zeros and ones. So ISP is the one which actually gives it colors and tries to give a actual representation what a human eye can understand. Does this need to be done even when there is a machine trying to understand this data, say for computer vision?
There we can use raw data directly, because information is available in monochrome, entire information. So there is no need of color. But for human interaction is required, there this debaying is required.
Understood.
But all other processing we can do it for both the raw data as well as color debaying.
So that is the reason why if we have stereo cameras, mostly stereo cameras are monochrome, because data is most important. You're getting the data and trying to calculate the depth. You don't need to represent it in image format, right?
Right. Exactly.
Understood. And what is the role of the right interface? What are the things that we need to consider while selecting an interface, or what is important in terms of selecting a processor as such?
So as embedded vision says, not only vision part, there is a decision part, correct? Decision part will happen on processor side, okay? And the image signal processor, it will only modify the image or video and other processing. So depending on application, processor can be placed in somewhere, and the camera main part will be there in different place, correct? So like a security surveillance. So sometimes the cameras will be placed in different, and actual decision making will happen in different place. So there is a distance between the ISP and the processor. Okay, so interface is the main one, which will decide distance. That is one of the parameter. Okay, if it is less than FE8, MIPI interface will work. Okay, and if it is less than 5 meter, USB will work. Okay, less than 15 meters, 5 to 15 meters, the interfaces like a GMSL and a PD link will work, where they serialize and they will transmit and deserialize. So there is a no loss in between data. And also these GMSL and FPD link will send the raw data directly without adding any overhead in the packets and other things. So latency will be less and it will travel longer. Okay, so these are the aspects. Even Ethernet is the one will add of overhead on top of data, so there is a latency. But a good about Ethernet is you can travel more than 15 meters. Okay, so we can send data from image ISP to processor even more than 15 meters. We can handle it. So these are the main thing. And also recently there is another interface came, ASA, like automotive SerDes Alliance. It is a 2.0 is available now. So even that major idea is serializer and deserializer, that technology also. So there is no proprietary technologies used in that. So it is agnostic to any companies and other things. Okay.
Understood. Understood. So these are standard interfaces which you choose basis the distance between the image sensor and the processor, and the latency requirements and the bandwidth of data, I believe.
Yes,
So,
correct. Some of the bandwidths depends on USB. It will work until 400 Mbps. Okay, maybe it can be higher. And the Ethernet, you can work on gigabit and 5 gig and 10 gig. Okay, you can handle much bigger bandwidth and data. These are the main aspects we need to see.
understood. Understood. So USB, even if we go for USB 3.0, which has a bandwidth of say 5 Gbps, because of the overheads, you mean the available bandwidth for data transfer is much lesser.
Yes, and also latency part of it.
Understood. Understood.
Say when we are taking working on real-time applications, latency is the major factor. Okay, even fraction of second or milliseconds are very important. So
Yes.
these are all things will help us if we are any other link without overhead in the processing.
Understood. Understood. So once we have the ISP, the interface, the sensor optics combination, what is it that we need to look at while selecting a processor as such?
So this is the decision part. Okay, we covered till now vision and even transfer of data, but major decision factor is the processor. Okay, nowadays we are saying AI accelerators, correct? GPUs and other, where 5 tops, 10 tops, 150 tops, and other things. So all these based on the data what we have. Okay, so resolution is one, where nowadays 20 megapixel cameras and higher also available. And other factor is frame rate. Okay, 60 FPS. Okay, frame rate per second. So 60 frames in 1 second. So if it is a frame rate is very higher, so the data what we need to process is also very high. Okay, that is one. And these are the two where data size will define. Okay, another one is application. whether you are using for edge application or a training application, LLM or a thing, then we need to decide on that. The other factor is power consumption. Okay, so if you are using for consumer electronics or IoT applications where single charge should work for multiple days or months or something, correct? So whichever is less power consumed one it is. So power consumption or that is also one of the factors required. Okay, along with the processing power. So
Understood. Understood. So with regards to vision, you will look at the data, basically the resolution. So that gives you the amount of data that is coming in each frame, then the number of frames, and the number of cameras connected to the processor. So that
exactly.
gives you data handling capacity. And on top of that, if there is some kind of an application to process it, you need to understand what is the processing power, and you need to understand what is the power requirement.
Exactly. See, some of the applications we require multiple cameras data. Okay, like autonomous broadcasting or any autonomous driving. These applications we need to capture data from multiple angles and directions and take a decision based on that. So we need to collect the data, stitch together, or different formats we can work on and need to take a decision. There are algorithms to process this data. Okay, so all these neural network process and other things, it is a computational intensive. So these are very important, like a resolution, frame rates, and application, whether it is edge application or processing power, and how many cameras are required. All these will be factored while deciding the processor.
Understood. Understood. Well, that was really informative, especially the breaking down of cameras into smaller blocks and understanding various facets in each of these blocks and trying to select a vision system basis those parameters that we need for our application. So I would now want to understand from the audience, like what questions or what doubts you have which you'd like to clear, and we can probably open up for the Q&A session. So I think we have one question from Shabazz Khan. What are the different types of data used in ISP? So I believe it's mostly raw data, if I'm not wrong, the YUV format. Is that correct, Srinivas?
Yeah.
Understood. Understood. So they can be different forms of YUV. It is the raw data that comes in from the sensor into ISP before debayering. And once debayering is done, you can still have an uncompressed format, which is still debayered, and then send it across. Raw data is not YUV. The uncompressed data after debayering is YUV. So the data that comes in to the ISP is raw data, gets some kind of processing done. And if it is compressed, it will go into the compression format. If it is not compressed, it will go into YUV format. The next question is, what is shutter speed and how does it affect exposure?
Yeah, like we discussed, speed is the major factor. Okay, global shutter application is what faster you want to capture data. Okay, so frame rate, whatever required. So these are all the factors decides. Okay, if it is faster speed applications, we need to decide.
Understood. Understood. So there is also a relation between shutter speed and exposure. So shutter is opening and closing of the sensor, right? The time when the sensor is trying to capture the data, that is called exposure time. So the more time you open the sensor, the frame rates would reduce. So they are inversely proportional. Shutter speed is inversely proportional to the exposure. I think that is the question.
So that depends on application, how much exposure time is required. So then we decide on the speed of the frequency.
Exactly. The next question is how to deal with discrepancy of illumination without compromising on FPS.
It's up to you. So I know field side you have much knowledge. You can go ahead with this.
Yeah, so we can increase the FPS in many different ways. Normally, what happens is in most cameras these days, you will have an automatic exposure, which is called auto exposure, which takes the exposure time basis the scene, and it once the scene is say having low light, then the exposure time increases because the sensor has to allow more light to come in for it to get something. If there is high illumination light, then you can easily control the FPS because there is enough light to come in and take the decision on the frame rates. And the other one is manual exposure, where you set the exposure time and the frame rates. There is another part where even in the auto exposure part, you can limit the exposure. Say it will be auto exposure till a particular limit. After that, it will not, the exposure time will not increase beyond the limit. So that way you can still have some control on the FPS. There is also ways in which you play with the settling time and all that to try to get an advantage and try to increase the frame rates. The best possible way of using it in a low illuminated area and having high FPS is having a high sensitivity sensor. So you can have Sony's Zero Lex sensors, or the Starwish series, or Starwish 2, Starwish 1, which can work in zero illumination as well and still give you higher frame rates. I have another question. What are the ISP settings and how do they influence image quality?
Yeah, that is what we discussed. So tuning is the best one where we see all the parameters and we'll play with the different coefficients required for this. Okay, based on the color correction or noise suppression, and various fields will take like a sharpness of the image and all other. So we need to read different manuals like ISP and camera lens, and also these are the main things we'll read and set the things. Okay, so we need to refer all ISP chip providers like a Qualcomm and NVIDIA and all other. So we need to set the parameter accordingly.
Understood. So ISP is an image tuning part, right? So you have a lot of controls there in terms of playing with the image quality as such. You can probably play with the gain, or say if you're not getting enough light, you can probably play with the gain, play with the gamma correction, play with various other parameters on the sensor front to increase the image quality. And as Srinivas said, there are different companies which have ISPs. You can have a third-party ISP, you can have ISPs on the processors, like you can have one on NVIDIA, one on Qualcomm. What kind of settings are available on these ISPs, which are given by these vendors, also plays a crucial role. For example, there are a lot of ISPs which are available on these processors, which do not support HDR. There are ISPs which support HDR. So HDR is a feature which you cannot get. So that plays a very important role, as he correctly said. The next question is, in case of sensor fusion with multiple cameras, can it be done with raw data or is it possible before delayering?
Before delayering is also possible. So that is the best where information is available 100%. So there is no. But if we required any human intervention, then we need to bring in delayering. Okay. Suppose you want to need some manual intervention somewhere. Okay. Then we go. Otherwise, in autonomous, that is good enough.
Understood. We have another question. What is the best dash camera for a car? So that depends on a lot of things.
A lot of things. It's not a company specific or something, but features we need to see. Okay.
Yeah. Something
what
that has
application
good IR
you
sensitivity,
using?
you can go with it. The next question is, hi team, what would be the main challenge in ensuring energy efficiency, then real-time processing, and especially for edge devices in IoT applications?
See, power and thermal, all these factors also involved. So while selecting, okay, thermal is also very important. Okay, so while designing processor and ISP as well as processor, so both are high power consumption one, and that will generate heat, and thermally also it will be red spots on that, and we need to be careful. And that depends on application, whether you are using it in outside of the home or all weather conditions need to work and all other. Okay, so that's it.
Understood. Understood. So the last question is how AI and ML are used in data processing.
Yes, so many applications. ML is the one where learnings are happening, and so most of the embedded vision applications are using AI ML.
Understood. Understood. So that is pretty much on the question and answer side. I would like to tell all the joinees that you can shoot in more questions. We have something called Consulting Thursdays that we have arranged for, where our camera experts will be available for free camera consultations. You can mail us and let us know what slots you are available at, and we can arrange for the right camera solutions expert and take it forward from there.
It's a free of cost.
Yes. All right then. So I think that is pretty much from our side. I think it was great talking to you, Srinivas. It was wonderful getting the information and understanding the construct of a camera and what parameters actually help us in selecting the camera. And all the joinees, thank you for joining in. Thank you for asking valuable questions and helping us understand this better. Thank you very much. Thank you, everyone.
Thank you all.